Alright, continuing on our review with Algebra 1. So solving linear inequalities now. We've got the less thans and the greater thans. The one rule that is different, or that you have to keep in mind when you add or subtract and start solving inequalities, is that when you multiply, you have to flip the sign. Flip the sign when you multiply or divide by a negative. And sometimes we just accept that without knowing the reason why. So if you look at this, we'll just fill in the blanks. Negative 2 and negative 5. Negative 2 is right here, negative 5 is right here. And so negative 2 is greater than negative 5. But if we divide both of these by negative 1, or multiply by negative 1, we get a 2 and a 5. And in that case, 5 is bigger than 2. Because we're talking about further to the right, bigger. And so the sign flips. And so we have to do the same thing when we're solving inequalities. So take this one for instance. We have a negative x, and so you would, to get rid of this negative, you can think of it as dividing by a negative or multiplying by a negative 1 has the same effect. So x is less than or equal to negative 4. And we're set with that. Now, inequalities, this represents it, but you can also represent it with a graph. And so negative 4, x is less than. All the values less than this are this way. But it's less than or equal to, and so we're going to fill in this. And there you have it. So that's our graph. Got an arrow going that way. Alright, so 3 minus 4x is 9. This is greater than 9. Let's get rid of this 3. So subtract 3 from both sides. 4x is greater than 6. Divide by negative 4. Warning, warning, warning. We divided by negative 4, so we got to flip the sign. X is less than. And then 6 over 4 reduces to 3 over 2, keeping the negative there. So on our number line we've got negative 3 halves. If you want to, you can include negative 3, negative 2, negative 1, and 0. Some people really like to include 0 on that. I mean, I don't really care either way. Whatever your preference is, so negative 1 and 0. Negative 3 halves, again, so this is less than, not or equal to, and so we're going to have the open circle on this one. Alright, number 3 has 0 less than or equal to, and then less than or equal to 4. This is called a compound inequality, or an AND statement, because 0 is less than this and this is less than this. Both of them have to be true. But we can solve it the same way, because this has it in common with both of them. So we're going to subtract 3 from the middle, subtract 3 from the left, and subtract 3 from the right. So you get negative 3 less than or equal to 3/4 x less than or equal to 4 minus 3 is 1. Then this is 3/4, so let's divide by 3/4. But dividing by 3/4 is really multiplying by 4/3. And so multiply everything by 4/3, left, middle, and right. The whole thing that happens in the middle is that everything cancels out, and you have the x by itself. So you can see that x is between Here, cross-canceling fractions, the 3's cross out because 3 divided by 3 is 1, and you get negative 4. And here, anything times 1 is itself. So, on a number line, we've got 0, 1, 2, 3, 4. I'm going to fill it in because it's or equal to. It includes that number. And we have 1 and we have 2, but what we have right here is 4/3. And so again, filled in, and x is greater than the negative 4 and less than the 4/3, and so that's what our graph looks like. And now number 4 has an or statement, so it's either this or this. We're going to solve them each as if they were separate problems. So let's subtract the 2 to get it away from the x. Subtract the 2, so you get 3x is less than negative 15. Divide by 3, x is less than negative 5. So again, I'm not writing the minus 2, I'm not writing the divided by 3. We can notice the difference between the one step and the next. And so we're just trying to conserve some time, conserve some paper. And then, so on this one we have to add 3. Add 3 to both sides because we have a negative 3. So 2x is greater than 10. 7 plus 3 is 10. And then x is greater than 5. So this or is very important because we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. X is less than negative 5 or greater than positive 5. If it was an and statement, this couldn't be true because there is no number less than negative 5 and greater than 5, but because it's an or statement, we can have both sides and we don't have any problems. Good luck solving inequalities.